Okay, so number one, like I told you, the same thing we did yesterday. It says, what is the error of the work shown? What is the correct answer? You're going to have to come up with the correct answer anyway, so go ahead and do the problem, right? So I have 1/3 times x minus 6 equal 12. And a lot of times people will distribute, some students will distribute the 1/3. But we did it a little bit easier, I think, is to get rid of the 1/3 by multiplying by the reciprocal, right? 3. So that those cancel out, and I'm left with my x minus 6 equals 12 times 3 is 36. Add 6 to both sides, and I get x equals 42. Now, they got 14/3, so you got to go back and figure out what they did wrong here. Well, it looks like they distributed the 1/3 because they did it properly, like unlike the problem yesterday. They did it properly here. 1/3 times 6 is 2. But then they added the 2. But when they went to go get rid of the 1/3, instead of multiplying by 3, it looks like they divided by 3. So that was their error. And that's what you have to write down. Okay? They divided by 3 instead of multiplying by 3. Okay. Now, a lot of these problems on the final tomorrow for the first part, they're going to be worth several points. Like this one might be worth 4 points. And the computation probably is going to be worth like 1 point, whereas the explanation will probably be worth 3 points. So I know a lot of students, they go ahead and do the computation, but yet they kind of blow off the explanation where it's worth the most points. So concentrate more on this than the actual computations because it's always worth more points. Okay, number 2, we have an inequality, right? What's the biggest mistake people or students make with inequalities? Yeah, flip the sign when you multiply by multiply or divide, right? By a negative number. That's the biggest mistake students make. And again, this will probably be worth more points than the actual solving, or it might be worth the same. So let's go ahead and solve this. We always like to treat with inequalities. We always like to try to get our variables on the left-hand side. So I'm going to subtract 7x from both sides. So I get negative 5x minus 10 is less than negative 5. So I'm going to add 10 to both sides. So I get negative 5x is less than 5. Divide by the coefficient, negative 5. And this is where that common mistake comes into play. Okay, we divided by a negative number, so I'm going to have to flip my sign. Okay, 5 divided by negative 5 is negative 1. And that's number 2. You could do it the other way. It's just, it's awkward saying it. Okay. But it's still right. All right, number 3. The biggest problem with absolute values? Have to make 2 problems. Okay, biggest mistake students make. So we're going to take what's inside. Oh, by the way, this is an or problem because it's a greater than sign. If it was less than, it'd be an and problem. Take what's inside. I always like to do my negatives first, so I'm going to go to negative 12. Flip the sign because I'm going from positive to negative. It's an or problem. Take what's inside and keep everything the same. Now solve each side. So I'm going to add 3. So here, x is going to be less than or equal to negative 12 plus 3, negative 9, or add 3, x is going to be greater than or equal to 15. That's my inequality solution. Go to graph it, my smaller number, negative 9, greater number, 15. It's an or problem, so that it's going to go out like both ors, right? Negative infinity, positive infinity. It's going to be my union right there. Let's see, we got an equal sign with the negative 9, so that gets a bracket. Same thing with the 15, has an equal sign, so that gets a bracket. So my notation, negative infinity always gets parentheses to negative 9. Negative 9 has a bracket. My union symbol, bracket, 15, and it goes out to positive infinity. Okay, number 4, solve by square rooting. This was the easiest one of the 4 methods we did, right? You have to get this x squared by itself. So you might as well just get that term by itself by subtracting 90 from both sides. So that leaves me with the negative 3x squared equals negative 75. Divide by negative 3, the coefficient. We don't have to worry about signs here. We're dealing with an equal sign. So you have x squared equals 25. Got to get rid of the power of 2, square root both sides. So x equals plus or minus 25 is a perfect square, 5. Now, there's I will take several answers for this one. The most common error students make? Yeah, definitely the plus or minus sign. Forget plus or minus sign. There's another common mistake. Students will take the square root of the x, but forget the square root of the number. That's another common mistake. So if you say either one of those, I'll take it. Okay? Number 5 is probably the easiest problem on the entire exam, right? Okay, you're going to go left 5 units. So left or right goes inside the math symbols, right? So here's my 5. Left is what? Plus or minus? Minus. Plus. Thank you. Yeah, it's opposite. You would think it'd be a minus, but since it's inside our mass symbol, it's the opposite, plus. What about outside the mass symbol? Stays the same, so I'm going to go up 4. No, that's a slope. Okay, they kind of. Huh? Yeah, I think that it's more of a formatting problem then. Okay. Number 6 is a systems of equations. This was way back in Unit 1. Okay. Abruzzo children are selling chocolate bars. So there's one of our defined variables, chocolate bars, right? And the other one is going to be popcorn. Popcorn tins. Now we have to decide whether it's the number or the price or what that specific is. All right, so let's go on and see what they have to say about all this. Well, Natalie sold, she actually used her kid's name. Natalie sold 12 chocolate bars and 5 popcorn tins for $45. So it looks like they give us the number, right? So we need the price. Okay, so we got 12 chocolate bars is X and 5 popcorns, which is the Y, and we collected $49. Her other kid, Logan, sold 8 chocolate bars. 8 chocolate is X, and 4 popcorn is Y for $36. We only have to set these up, so we're done. That's it. And then the domain and range. What's the easiest way to tell if something, when you have a graph, what's the easiest way to tell if something is a function? Vertical line test, right? So I know these points are big. They're not supposed to be. So if my vertical line passes through more than one point on the graph, then it fails the test. But here, it passes the test from beginning to end. So yes, this is a function. Passes vertical line test. All right, let's look at the domain, which is the x values, right? So I'm going to start at the beginning here, bring it up to my x-axis, and it looks like -7. Includes -7. And then the end of the graph ends at 6 and includes 6. And then the range. Well, my lowest y happens to be the beginning of the graph, here at -7, right? And then the highest point is right here at 8. And that's the end of part 1. Part 1 is actually very doable, right? Should get a high grade on part 1 at least, right?
Yes.
Yes.
I will. I won't.